Hi everyone. Good morning. Yes, so what was the last topic that we have discussed? What did we discuss in the last session?
Grouping using aggregate functions.
Yeah, order by, group by. Okay, okay. Just give me a minute. I'll just check the syllabus. So let's see in this thing, uh, pivot table, date and time functionalities, manipulating data frames that we are going to study today. Uh, Rest of the things, introduction to Pandas series, data structure, querying and indexing data frame, data structure, querying, indexing, loading and merging data frame. We already have discussed this. This one, the map function, we already have discussed. Python PIP, iterators, pickling Python, JSON Python, API, and web scraping. This we'll discuss today. Then I think one more thing is remaining. That is math function, MATH. This is also something that we are going to discuss today. So by the end of this session or this weekend, we are going to finish everything related to pandas and Python, right? This thing. And most probably, we are planning to start this module 5 in tomorrow's session, this data modeling and normalization. But I wanted to give you some case study as part of your live classes. So it might happen that uh, we'll require extra 1 or 2 sessions to cover this module, which is this one. We'll see this thing, yeah. But we'll see a practical implementation or case study of everything related to pandas. So that is very will be very helpful for you, right? All right. Then in the last session, this was your last session. We have seen operations on data frame. We'll continue with that only. Yeah. Meanwhile, if you have any questions, you can ask in the beginning itself. If you don't have, we'll go with the next part. Yes, anybody have any doubts here in group by? All right, so I'll restart and run all this. And in this thing, we have seen group by and aggregate function, pivot table, merging data, joins and concatenation. This is remaining, right? So we'll start with that. So let us give heading as, let us give heading as merging data frames. Now in this segment, you will learn how to merge, concatenate multiple data frames. In real world scenario, you would rarely have the entire data stored in a single table. You will rarely have this entire data stored in a single table to load into a data frame. You'll have to load the data into Python using multiple data frames. So you might have multiple data set. This is CSV file one. This is the second CSV file. You will be having another CSV file. So you have to merge that data frame in real world scenario, right? You'll have to load the data into Python using multiple data frames and then find a way to bring everything together. So this is why merge and append are the most important operations or most common operations that are performed in data analysis. You'll now learn how to perform this task using different data frames. First, let's start with merging. The dataset that you have been working with contains only weather data, right? Only weather data, not sales data. We have not imported the sales data. Yes or no? So the dataset in which we on which we were working contains only weather data, not the sales data. And sales data stored in some other another different data set, which is this, right? This one. We are going to read that. So how would you combine these data sets? Let us find that out. I have one question over here. So you have asked to find median and mode for minimum temperature, maximum temperature in the last class. Mode we cannot find. We'll see that. We'll see that. I have asked you guys to calculate median and mode. Okay, this one, no? Yes, we can do aggregate function for that, AGG. We'll see that in today's session, AGG. Aggregate function is something which we use to find different statistical values. Right? We'll see that today, Darshini. Okay, so what we'll do is let us read another data that we have, which is sales data, and let's start to do this thing. Yeah, so I'll put example 4.1 as merging data frames. And yes, there should be fifth jump. Okay, so the join the join command is used to combine data frames. Unlike your H stack and V stack, the join command works by using a key to combine two data frames. For example, the total T for the new castle store for the month of June 2011 is given in the file names that particular file, right? June sales dot csv. It's not here. I have given you guys this thing. Let's see that. So we have to read in the data from the file and join it to the weather data extracted from the original data frame, right? So what we'll do is here we'll quickly upload June sales data. I will share you the drive link. I'll share quickly. You might have that, right? Drive link. Yes or no, guys? Do you have drive link with you?
Yes, Vipul.
So on your drive, you see yes, if you see, I have given June sales data. Can you see that? June sales data. It is in day 8, I think. Day 8. Yeah. If you see day 8, if you go to day 8, operations on data frame. Okay, I'll share that link. You can download that data. Yeah, this is your data. Just download this June sales data, everyone. So uh, now we'll read this file. So I'll write down sales is equals to pd dot read underscore csv, and June sales data is something that I'm going to read, right? If I run this, okay, pd, it's pd. And if I just check sales dot head, this is your data, right? Now in this data, I wanted to add one more column, which should be day of month, because in order to merge two data frames, you should have a common column between them. So here we have day of month, right? Here we have day of month, and here also we should have day of month, right? We should have common column only and only when if you have common column, then you can merge these two data frames. right? So how to create this? By using same function, I'll write down that day of month. And remember, it should be in same fashion as of your this data, this column. So days, D is capital, M is capital. Here also D is capital, M is capital. And it should be pd dot date time index. From this data, I want to play with this date column and I want to extract only day of that. And if I write down sales dot head, okay, date time index, spelling is wrong. Index. Can you see this? We have one more column, right? Is this thing clear to you, everyone, why we are doing this?
Yes, people.
All right. So let us filter the sales data for the relevant month and the appropriate location to a new data. Let us filter the sales data for the relevant month and the appropriate location for the new data frame to a new data. So I'm creating a variable Newcastle data from the data uh, from data frame data. I'm extracting a location is equals to this one Newcastle and condition from the data frame year column that has to be equals to 2011 and one more condition uh, data month column month column that should be exactly equals to 6. That should be exactly equals to 6. And I think the spelling is wrong. Let's make it correct. Newcastle data is the variable name. And if you just write down that, okay, if I run this, and if I just check what is there in Newcastle data, no condition is getting satisfied, is it? Just okay. We have this data column. In that, we have, do we have location? Yes. Do we have year column? Yes. Do we have month column? Right.
You have to close the bracket after 2011, I think.
Yeah.
You have to close bracket X to 2011.
Next to
2011 year.
right. Yes, exactly. And they should not be there. This one, right? So we are getting a data wherever there is a location is equals to Newcastle, year is equals to 2011, and month is equals to 6. So we are just filtering the sales data for the relevant month and the appropriate location to a new data frame, right? Okay, this is what we have. Then what we'll do is we'll see merging, how to do merging. So we'll write down merge underscore data, the data frame name, Newcastle data, which we have created just now. I want to merge this with sales column. And on which common column? We have this data and we have sales data. Column is common for them? It's day of month, right? Day of month. So we should mention that. We should specify over there on which column. So on is equals to that particular thing. And if you check merge underscore data dot head, let's say first 10 records. So this is what you are going to get over there, right? So what we do is we write down dot merge function, right? We write down first data frame df1 dot merge df2, and on which column? It should be day of month column, day of month. So we should specify on which column you wanted to do this, right? Now, let's take another example. Yes, is it clear, guys? The above part, merging part. Do you have any questions in merging? Yes, everyone? Is this thing clear? Merging operation? Okay. All right. So the next is we are going to see types of joins. So we have inner join, we have left join, we have right join, and we have full join, right? And each state may have different tax laws. So we might want to add the state's information to the data as well. And the file is locations and states.csv information about the states and location, right? So the data in this file is not same as weather data. It is possible that few locations in data, that is original data frame, are not in this file, and all the locations in the file might not be in the original data frame. So in the original data frame, and we need to add the state data, right? So you go to your drive, you'll find that you have one more data set, which is locations and state.csv. Locations and state.csv. The same drive link which you have with us, which I have shared yesterday, not yesterday, last session. You can take out that. Can you see that? The locations and state CSV, everyone? Can you see this file? Yeah. So let us upload it over here first. Locations and states. Let's upload here. And let's create one more file, one more data frame. State is equals to pd.read underscore csv location state csv comma header is equals to 0. And if you check state dot head, this is your data, right? Now we have one common column between state data and data data frame. Which is that common column between these two data frames?
Location.
Location is common, right? So what we'll do is we'll write down state underscore data is equals to data dot merge state comma on is equals to location and how is equals to left join, and we'll write down state underscore data. Left. Okay, L is small. The syntax is small L. So what we are doing is we are doing a left join, which is nothing but suppose this is your left table, this is your right table. How you can identify which table is your left table, which table is your right table? So the data frame that you write down first is considered as the left table, and the data frame that you write down as a second is considered as second, right? So we are doing join on this. Which type of join? It is left join. So all the records from left table, which is data table, all the record from the left table it will take, and only common records between left and right table, that is this, right? This one. All the records from the left table and common records between the right table it will give us. So basically, the records which is not common between left and right, it will exclude this by using left table. If you are doing right join means all the records from the right table will be there and common record between left and right table will be there, right? And inner join means only common records. Outer join means all the records between left and right table. So this is our four type of join: inner join, left join, right join, and full join. Right. So here we are doing the left join, which is nothing but all the records from the left table and common record between left and right table. So we are going to get this, and this is what we have. If you see, this is how you do the join, right? So you go through this. If you have any questions, you can ask. We'll take a 5 minutes break over here before going further with the pivot tables. And if you have any questions now, you can ask. Yes. Do you guys have any doubts in this? So it's 9:41. Let's have break till 9:47. And after the break, we'll go with the pivot table. All right. So what is a pivot table? It's quite a useful tool to represent data frame in a structured and simplified manner. It acts as an alternative to the group by function in Pandas. Uh, a pivot table provides Excel-like functionalities to create an aggregate functions. So if you would have worked in Excel, you might have seen this pivot table, right? You might have seen this pivot table. So it's same like your group by functions, which is there in Pandas, but it is another quite useful tool to represent data frames, right? So a pivot table is quite a useful tool to represent a data frame in a structured and simplified manner. It acts as an alternative to the group by function in Pandas. A pivot table provides Excel like functionalities to create aggregate tables. Right, so let us see this. How do you create a pivot table? So before that, okay, suppose you have been given this question that using pivot table, you need to find the average monthly rainfall in the year 2016 of all the locations. The information can then be used to predict the sales of tea in the year 2017. Right? So what I'll do, I'll write down data underscore 2016 is equals to data of year. So I think Y is capital column and only specific to 2016. Now if you check data underscore 2016, you'll see that this is your data. Only 2016 records are there in this data frame. Now, what I wanted to do is data underscore 2016. Let's create pivot table. So the function is pivot underscore table. In that index for the output, that it should be index means this one, right? We already have seen, no? This is your index, right? So 1, 2, 3. Instead of that, we are setting index as location. And then there will be columns 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that, right? Then there will be columns. So I'll write an index is equals to location, comma columns is equals to month, comma values is equals to rainfall, and comma agg function is equals to mean, right? Agg function is equals to mean. So this is how you create a pivot table. You write down that particular data dot pivot table. Index I want is in location and columns I want it as month. And which function you want? Mean. So mean of Adelaide for or mean of rainfall for this particular city, Adelaide. Mean of rainfall for the first month is 1.702326. Or Albury, mean for April is rainfall is 0.54667. Right? So this is one of the most powerful tools that we have in uh, your Pandas library. Right? Now to go with the I mean, if you have to go in details for this, you can go to official documentation. You can directly search Pandas tutorial pivot table, and this is your official documentation. Right? This is your pivot table. So you can read about that as part of your extra material. Now, now this information can be used to decide the stocks of tea in each of the stores, right? Based on, as you know, rainfall is directly proportional to the sales of tea, right? If we have a region where there is less rainfall, so this tea is less likely to sold over there, right? The sales of that particular region for this segment tea is less. But if rainfall is high, so naturally tea sale will be high, right? So this information that we have calculated, average rainfall of city or location month-wise, average rainfall of location month-wise, will help you out to decide the stocks of tea in each of the stores, and you can modify the pivot table command to a get a lot of work done quickly. To get a lot of work done quickly, right? So I'll write on data underscore 2016 dot pivot table index same. Let's take location, comma, columns is equals to month, comma, values is equals to sunshine, comma, AGG function is equals to mean. Now this time it's sunshine, not rainfall. So for sunshine column, we are analyzing this by using pivot table. So that's all you have for the pivot table. Based on your experience or your expertise, you can discover this function to get some insights about that, right? So where there is high sunshine, you can see that the sales of umbrellas will be less for that region, right? If if there is high sunshine, means sunshine is good, rainfall is less. So obviously, uh, the sales of this particular segment is less, right? So that's what we have for this pivot table and operations on data frame. Now, if you have any questions, you can ask. Otherwise, we'll move towards the practice exercises. Yes, anybody have any doubts now in this? Yeah. Abdul, Achuraj, Arvind, Arun, Binu, Chandramohan, Darshini, Gopi, Hari Krishna, Janani. Avantika, Kannan, Karthik. We have two Karthik, Madhu, Maulya, Murali, Prashant, Prasita, Sharmila, Srikaran. We have Varun, Karthik, Venu, and Vijay. Yes, everyone. Anybody have any questions? All right, then, perfect. Let's go to practice exercise. This is really interesting. Here, it's kind of test for you to judge your understanding of pandas, right? So let's do that. But before that, I'll quickly upload uh, the data which you'll require for this case study. So I'll do it in on your drive under the folder of this day 9, 2nd November, day 9, 2nd November, and the data is just a minute. Let me check that. It's kind of zip data, zip air pollution COL. Okay. So day 9 folder, I'll create practice exercise 1 folder. In that, I'll upload the file. Yeah, this one, right? And you guys will require one more Python notebook for your questions. Questions, this one. So this is your drive link. Everyone quickly download your data. You need to unzip that file first, which is given. That is your data set. And it is, I think, 210 MB, right? So we have multiple data set in that. You just need to download that. So we have three data set: measurement info, measurement item info, and measurement station info, right? So let's do one thing. Let's take this three data set. Let's take this three data set and let us upload it in your Jupyter notebook, right? Let us upload it over here. We have this three data set, 1, 2, and 3. Let's open this. So info, item info, and station info. This info is little heavy. It will take some time to load that particular file. It's I think 120 MB. Right? Now let me know if you're done with this so that we can start this question. Right? What you have to do is you have this IPYNB notebook, which is questions, and you have to upload these three data sets: measurement info, measurement item info, and measurement station info. Right? So let me know if you're done with this so that we can start quickly. So the question is, can we start, everyone? Yes, guys. Can we start? I can see only one response. Okay. All right. All right then. Excellent. So the question is, air quality data for this segment has been divided into three different CSV files. Info.csv has the data R by R data about the concentration of pollutants in the air and the status of the instruments. The item info has the data for items and level of concentration. Station info has the data for measuring stations, right? Now you have to read in all the three data sets and then print the first 5 rows. This dataset is already available on Kaggle. We'll discuss a few points about Kaggle. I'll explain you. I'll explain this point. What is Kaggle and how you can use that efficiently. But let's do this after this exercise, right? Okay, so we are importing necessary libraries, which is Pandas, importing Pandas as PD. Now we have to read our data. So data should be this measurement info. So what you can write? pd.read underscore CSV. You need to give measurement CSV measurement.info. And if you run this, and if you check what is there in data dot head, so this is your data, right? This is your first question. Second question, again, it's very easy. You need to write on read the item. So you'll write on pd.read underscore CSV measurement CSV measurement item info dot CSV comma, or you can read this. And if you check what is there in item dot head, so this is your data. Third is station. So let's call it as station is equals to pd.read underscore CSV. Or is it? Station is equals to pd.read underscore CSV. Add measurement station info dot CSV. And if you write on station, you'll get this. Right? Now your first question. You need to create a new data frame which has information about the item code and item name. Only two columns should be there. That is item code and item name. So how can you do this, everyone? Item code and item name. How can you do this? Only subset of this data. It's very simple. How can we do this? So it should be item. Here, shall I use single square bracket or double square bracket?
Double.
Double, very good. So I'll write on double square bracket, item code, comma, item name, right? And if you write on sub underscore item, this is your data. Is it clear? This part? Now, another question, create a new data frame which has information about the station code and station name. Again, a very simple thing. Station data frame, double square bracket, station code, comma, station name in bracket. It should be district. Write down sub underscore station. This is your data. Substation dot head. Now you have question in the data frame. You need to add a column displaying the names of the items. In the data frame, you need to add a column displaying the names of the items. So you have a data frame. You see, this is your data frame. In this data frame, you have to add a column of which should display names of the item. So it should be item code. Item code. So it's only merging the column which is item code in your data frame. So data dot merge. You need to write in sub underscore item. Comma on is equals to item code. Comma how is equals to left. And you write on data underscore I dot head will be your, okay, comma should be there. So this is your data in which you have added item name. Sorry. Yeah. You have added item code as well as item name. Because if you see, we have created sub underscore item. In that we had item code and item name. So this is what it is. This is what you have over here. Right? Is it clear? This part? Yes or no, everyone? Okay. So in the data underscore I data frame, you need to add a column displaying the names of the station. Names of the station. So again, substation is something which we need to add over here, which we have created earlier. Sub underscore station. Sub underscore station dot head. Right? This we should add over here. So we'll write on data underscore I dot merge sub underscore station come on is equals to station code comma how is equals to left, and you'll write on data underscore head dot is dot head, this part, and you can see we have added this to substation and station code, station name and station code, right? Again, another question is you need to drop the columns station code and item code, as this column have not become redundant, and you can find the relevant information functions in this library over here. You have been given the official documentation over there, right? But as of now, we need to drop this two columns, station code and item code. So how do you drop column generally? Let on data underscore is. This was your data frame, data underscore is dot drop. What you need to drop? Station underscore code. This one, comma item code, comma access is equals to 1. And you can write on data dot head. Data dot head. This one. So you can see that we have dropped this from the access equals to 1. What is your access equals to 1? Do you remember this? What is your access equals to 1? Column wise, right? Axis is equals to 1 means column wise. And if you need to drop rows, let's say you need to drop row number 1. So you'll write down axis equals to 0 for that. See, if you want to drop rows, then you should write down data dot drop. You need to drop row number 1 and you need to write axis is equals to 0. So row number 1 is dropped, right? Can you see this? So axis is equals to 0 is for rows and axis is equals to 1 is for columns, right? Now next question. Given below are the meanings of the values in the instrument status. Normal need for, if it is 0, then that instrument is normal. If it is 1, then that particular instrument will need calibration. 2 means abnormal. 4 means power cutoff. 8 means it is under repair. And 9 means it is abnormal data. So using the information given above, you need to add a column in the data frame in the data frame to give the status of the instrument and then drop the instrument status column. And hint is you need to first create a dictionary from data and then use same dictionary to create a data frame and then merge the data frame with the data, right? First create a dictionary from the data and then use the same dictionary to create data frame and then merge the data frame with the data, right? So how can you do this? First, we'll create a dictionary from the data, and then we'll use same dictionary to create a data frame. So let's create this dictionary. We want to create a dictionary like this. So a dictionary is created like this. Instrument status is equals to 0, 1, 2, 4, 8, 9, right? Comma. Next column should be status is equals to normal, need for calibration, abnormal, power cutoff, under repair, abnormal data, and you'll write on status underscore DICT to get this in the form of a dictionary, right? And then this dictionary should be converted into data frame. So it's very simple. PD dot data frame, D is capital, F is capital. And what you need to convert into dictionary? The status underscore dict, which you have created, this status underscore DICT. So if you run this, you're going to get the output for this. And then what is your question is, you have to drop, instrument status column. But first of all, we have to merge this two data frame, this data and the one which we have created, status underscore DICT. And which is your common column between this two data frame now? Yes, everyone. Which is your common column? How should we merge this two data frame?
Instrument status.
Right. So you write down data dot merge DICT DF comma on is equals to which column? Instrument status. So copy this and you're going to paste it over here. And let's do left join. left, how equals to left. And if you check data dot head, we'll get the same output over here, which is this. Now what you need to do? This is created. But what is your another question? You need to drop the instrument status column. Now, if it is column, the axis should be
1.
very good. It should be axis is equals to 1. Data. And if you write down data dot head, which will give you the same output over here. So this was your question. You can try this out. I'll take a 5-minute break. And after the break, we are going to solve this question. You need to extract the time series data, that is year, month, date, and hour from the measurement date column. So PD.date time index is something which we are going to use. You can literally refer to the previous case study that on which we are working on. And once the date, all the data is extracted, you need to drop the measurement date column, right? So PD.date time index, everything will be there. Only dot year function you need to use, dot month function you need to use, dot day function you need to use, and dot hour function HOUR you need to use, right? So try this out, everyone. Write down this. All right. So now we need to extract the time series data, that is year, month, date, and hour from the measurement date column. So what should I write for this? I'll write on pd dot date time index data. The data frame name is measurement date dot year, right? Then for month, you can copy this, paste it over here. Instead of year, it should be only month. Again, next is this. Instead of year, it should be day, and hour instead of day, it should be hour, right? And now if you check the head of your data, now if you check your head of the data, you are going to get year, month, date, and hour column, right? Now, what is the second question? You need to drop, once all the data is extracted, you need to drop the measurement data column or measurement day column, date column. So write on data dot drop. Which column we need to drop? Measurement date. So you'll take this out, you'll paste it over here, and you write down axis equals to 1, right? And now if you check data head, so you have successfully removed the or dropped this column, which is your measurement date. Now, is this thing clear to you, everyone? Is it clear? Do you have any questions in this? Yes, everyone. All right. So, as a practice, as a homework, I'll share one more practice exercise with you that you need to solve as part of your homework, right? So this is something which we are not going to do live. Let me upload that. Just a minute. Practice case study 2. Hmm. Yeah, this is your exercise, and you will require data for this. So that data is movie dot csv. This, yes. So this is your homework for today, which you need to solve. So we have a practice exercise notebook over here. We'll just walk through with that notebook. In this assignment, you will try to find some interesting insights into a few movies released between 1916 to 2016 using Python. You'll have to download movie dataset, write Python code, and explore the data, gain insights into the movies, actor, directors, and collections, and submit the code. Right. So these are some tips that is provided, and you need to read the data. And these are the questions. How many rows and columns are present in the data frame? How many columns have null values present in them? Right? Clean the data, count the columns in new data frame, inspect null values, and which column has the highest percentage of null values, fill the null values. I think we have not done this, no? Filling the null values and null values calculation. This is not done, no? So now we are going to do this anyway, right? So our next agenda for today's session is very, very important, which is your uh, cleaning data cleaning, right? This is very important, guys. But before that, let's summarize our learning from this Panda session. So let's summarize this, whatever we have discussed till now. And then we'll start with the cleaning part quickly. So here I'll write down summary and let's summarize this module. So first point, we have seen Pandas, series, and data frame, right? Which are the basic data structure in the Pandas library. Second point, indexing, selecting, and subsetting a data frame, merging and appending two data frames, which can be done using the dot merge and dot concat commands. Grouping and summarizing data frames, which can be done using group by to first make an object and then use it to play around. Then the pivot table function in a data frame, which is similar to pivot table in Excel. Finally, you learned how to perform different functions over time series data using Pandas. So this is a summary, right? Now, now let us create a new folder. Let's rename that as today is 2nd November, right? Second. And this is our third module for Python for data science, getting and cleaning data, right? Let's create new notebook and let us start to learn this. So very first thing is, let's have some introduction about this topic. So there are multiple ways of getting data into Python depending on where the data is stored. The simplest case is when you have data in CSV file, right? But often you need to get data from other formats too, other sources and documents such as text file, text files, or relational database, or websites, or APIs, or PDF documents. PDF documents. So you have CSV file, text file, relational database, website, APIs, and PDF documents, right? Now in the following sections, you learn to get data into Python from a number of sources And you learn to get data from text files, data from relational databases, which is SQL. You learn how to scrape data from websites, how to get data from publicly available APIs, and read the PDF into Python, right? So in the process, you learn how to deal with nuances that inevitably come while getting data from various sources, right? So this will be our agenda for this particular session. So we'll write down. You will learn get data in Python from a number of sources. So you need to get data from text files. You need to get data from relational databases, to scrape data from websites. You need to get data from publicly available APIs, and you need to read PDFs into Python. Now, in the process, you learn how to deal with nuances that inevitably come while getting data from various sources. So let's put first heading as reading delimited and relational databases. So very first thing is getting data from delimited files. What is delimited files? Are usually text files where columns are separated by delimiters such as commas, tabs, semicolons, etc. And each new line is a row. Each new line is a row. Now, how do you get data from relational databases? Its data is commonly stored in RDBMS, and it is easy to get it into Python. We'll use most common one, which is MySQL. There are many libraries to connect MySQL and Python, such as there are many libraries to connect MySQL and Python, such as PyMySQL, MySQL database, etc. And all of them follow the following procedure: connect MySQL. So we'll create a connection object between MySQL and Python. And to create a cursor object, use a cursor to open and close connection, and you need to execute the SQL query, and you need to retrieve results of the query using methods such as fetch one and fetch all. Fetch one and fetch all, right? Okay. So the very first thing that we are going to do in this module is we'll see how do we get data, right? So we'll import numpy as np, import pandas as pd, we'll read the file. The file that we are going to take is txt file, text file. Earlier, we were taking CSV file, which is comma separated file. If you see, for every values out there, it is separated with comma. Can you see this? That's why it is known as CSV. Every value is separated with comma. Each value is separated with comma. So that is your comma separated value CSV for you. Right? Now, the file that we are going to take in this module is .txt file, right? So I'll quickly upload that. I'll share this with you as well. Just a minute. File name is companies txt. Okay. Let me take that file and let me upload it as well on your drive. Okay. Files here. Companies.txt. Right. So quickly download this and I'm going to upload it on your drive. Day 9, 2nd November. New folder I'm going to create it as getting and cleaning data. Getting and cleaning data. And in that, let us upload this. Okay. And this is your drive link. So let us upload it over here, that file. companies.txt. And if you just try to open that, it is it cannot open over here. But if you just open that companies.txt in your notepad, so that is your text file, right? It is separated with a tab, not a comma. It is separated with tab. So how to deal with such type of files now, right? So what we'll do is uh, let's write on that reading companies file throws an error. Reading companies file throws an error. Companies is equals to pd dot read underscore csv companies dot txt comma separator is equals to other slash t. If you write down, this will throw an error, right? It will throw an error. So what we should do for this then? The error occurs because of decoding issues Pandas is facing. The best way to resolve such problems is to search for help, for example, on Stack Overflow, where you would get excellent suggestion from the community. As I told you, that is very, very reliable. If you just directly search this, no such files directory, is it? If you just search this, and if you go to Stack Overflow, you'll get a resolution to this error, right? This one. So this is one of the solutions that we can have for this problem, or you can do the encoding. So let's put that heading as using encoding. ISO 88591. So how should we do this? We should write on companies is equals to pd dot read underscore csv. File name is companies dot txt, comma. Here it is a tab, no? So separator should be other slash t, this one. So it is separated with next line, right? Separated with a tab. And you should write an encoding parameter attribute argument is equals to 885921. And if you write down companies dot head, you'll be able to get this output, which you will find that we can easily read that data, right? So it was separated with a tab. This will take care of that, and encoding will take care of this error. So that was the first part. Second is getting data from relational databases. So it was this actually. So I'll just take that. I'm going to paste it over here, right? So I'm going to import PyMySQL. That is one of the libraries that we have. Even though this is not important and this is not covered in our syllabus as well, but I'm taking you this as a part of your extra activity. You will find that you will use this very rarely, right? So it is not that important, but you should know how do we establish a connection between Python and SQL. So I'm writing down this con is equals to PyMySQL dot connect host is equals to local host comma, your host, comma, local host for your local machine. User is equals to root, comma, your username. Usually root for local host. Password is equals to your password, comma, database is equals to world. So it is nothing but name of the database. World comes inbuilt with MySQL. Right? Now we are going to create a cursor object C. So C is equals to con dot cursor, open and close bracket. We need to execute a query using C dot execute. C dot execute. So select star from city. This is your SQL command, basically. I want to execute that. Anyway, we are going to learn that uh, in SQL module, this one. Now getting the first row of data as a tuple. Getting first row of data as a tuple. So we'll write down all underscore rows equals to c dot fetch all, open and close bracket. And to get only the first row, we need to use c dot fetch one instead. Then user is equals to should be there, no, not this. Yeah. And no model name is by MySQL. Okay. Not there now. Okay, I need to import that, no, install because it's not there. We need to install this by SQL. So this is not there in our system. We need to first install that by using this command pip3 install mysql, and then you can import that. So let us try to install this first. Okay, this is not working. What about this? Yeah, it is getting installed now. And once this is done, you can literally have leverage to comment this line this way, right? And if you restart and run all this, you'll not get this error. Yes. Access denied for localhost using password yes. Okay. Yeah, now you need to identify your localhost password. For this, you need to use that particular password over here, which you are going to set it for SQL, right? So let's write down this as a black box. You can literally use this module whenever you want to read your SQL file. As of now, I'm not able to recall my password for the local host. Let's keep that particular thing. Now, you need to notice that it returns a tuple of tuples, which is each row is a tuple. I need to print type of all rows, and you are going to print the first few rows over here. You need to print all underscore rows. In that, you'll write in first five. So as this is not working, so you'll not get this output. But you can try this for your system, and you can write down your own password for this for your computer, for your system, right? And I'm unable to recall what it was. Also, okay, okay, that's fine, not an issue. Now, now it would be useful to convert the list into data frame, since you can now work with data frames easily. Since now you can work with data frames easily. In this case, you can use pd dot data frame function and pass the list version of the tuple. Right? I'll add in pd dot data frame list of tuples to convert each tuple in the list to a row in the data frame. So you write down this, and then you'll start working with the analyzing data from the SQL data. pd.data frame list of all rows that you are going to check. Columns is equals to ID, name, comma, country, comma, district, comma, population. And you're going to write down df dot here. This is second part. In this way, you can read your SQL data from relational database. And now it's time for your third uh, type, which is nothing but getting data from websites. Now, this is again very, very important part. How do you read data from websites? It is known as web scraping, which refers to the art of programmatically getting data from the internet. Once One of the coolest features of Python is that it makes it easy to scrape your websites, right? Now in Python 3, the most popular web scraping is Beautiful Soup library, which you should remember, or you should know. Beautiful Soup is a library which we use to extract uh, websites, data from websites. And to use this library, Beautiful Soup, we will need We'll also need we'll also need the requests module, which basically connects to a given URL, which basically connects to a given URL. And I can say it fetches data from that particular URL in your HTML format. This is very important. It will fetch data in HTML format, and you need to do some data pre-processing on that to extract that particular data. So a web page is basically HTML code, and the main use of beautiful soup is that it helps you parse HTML easily, right? And discussion on HTML syntax is beyond the scope of this module, which is not something you should know. Discussion on HTML syntax is beyond the scope of this module, because we are not going to learn HTML in this session. But though even very basic HTML experience should be enough to understand web scraping. Now, use case. The use case that we are going to solve over here is fetching mobile app reviews from Google Play Store. So let's say you want to understand why people install and uninstall mobile apps and why they like or dislike certain apps, right? So you want to analyze this, or you want to understand why people install, uninstall mobile apps, and why they like or dislike certain apps. A very rich source of app reviews data is the Google Play Store, where people write their feedback about the app. And the reviews of the Facebook Messenger app can be found on a website, which is this play.google.com. Show apps. Okay, I'll just take that link and I'll share with you. Just a minute. Yeah. Okay. Let us take this review from this one. This is your link. So it's Facebook Messenger app, and you can see below there are the reviews from the users, right? So the reviews of the Facebook Messenger app can be found over here, right? Now what we are going to do is we will scrape reviews of the Messenger app, that is get them into Python, and then you can do some interesting analysis on that, right? So let's see this. Uh, so what we will require is, let's give heading as passing HTML data using beautiful soup, and requests to start using beautiful soup and to install it using pip install beautiful soup 4, and you need to load the module bs4 using import bs4, and also you need to install the requests module using pip install requests, and the general procedure to get data from website is to use requests to connect to a URL and get data from it. We have to create beautiful soup object. Third, you need to get attributes of the beautiful soup object, that is the HTML elements that you. So we'll import requests and BS4. It's already there in my system, but for you guys, you need to install uh, this one, your beautiful soup. So for that, you need to write down pip install beautiful soup 4. You run this, it will get installed, and then you can use BS4. But as you know, it was there in my system, so I'll just comment this, and here I'll write down this. Now I need to get the HTML from the Google Play web page. URL is equals to, let us take this URL and let us paste it over here. Okay, this is not the one that we are looking out for. It should be this. Just a minute. Anyway, it's same, but okay, let us take this. Let us take this and let us paste it over here. So this is your URL, and request is equals to request.get URL, request.get URL, and you need to create a BS4 object to avoid warnings. Provide HTML to provide warnings. You need to provide HTML five library explicitly. Soup is equals to bs4 dot beautiful soup request dot txt, sorry, text, and comma. This should be HTML5 library. Now once you have a bs4 object, you can use it to get specific parts of the HTML document. In HTML, the most common elements are either part, class, or are signed and ID. A typical HTML code looks like this. So it is like this body, and it has division. Class equals to some class. Then we have P ID is equals to a unique ID and a paragraph that you can read on the web page here, and then slash p slash div slash body. So this is your HTML sample code. It looks like this. And the easiest way to get specific parts of the web page is using soup.select method. So the easiest way to get specific parts of the web page is using the soup.select method. For example, soup soup dot select div, it will select all elements inside a div tag. So this soup.select div selects all the elements inside div tag. Then we have another command soup.select div this p. What this will do is it will select all the parsed element which is there inside elements within your div tag. And there are some commands. There are some other commands that we need to remember. Soup dot select dot sum underscore class will select elements inside class is equals to sum underscore class. And then we have last but not the least, soup dot select sum underscore id. What this will do is it will select all the elements inside the id is equals to sum underscore id element. Now you need to find the IDs, classes or divs, divs, etc. inside which the reviews are located. To find those, you need to go to web page, right click and choose the inspect. It will open up the HTML code, right? So we'll take this up. We'll go to this page. You will right click on this. We need to use this inspect, this one. And here you'll see that this is your HTML code, this one, right? And we'll not go into details, but if you look carefully, all the reviews are located inside div, right? So just a minute. All the reviews are inside your div class, right? So we can use that class to fetch the reviews, right? So let us write down that here itself. Now let us go to next cell. Let's write down all the reviews are located inside a div class is equals to review body. So we use that class to fetch the reviews. So so we need to write getting all the text inside class is equals to review body. Reviews is equals to soup dot select review body. I need to print type reviews, and again you need to print length of reviews. I need to print the other slash n, and right on printing an element of the reviews list. Right on print review square bracket 6. Still out of range. Okay. For this, you'll require one more data that is not loaded over here. Just a minute. Let me check this HTML5 library. So text. So, so, I'm not taking up all the reviews. Now there should be link, no? Right. Here it's not coming as a link. First of all, if I just take this here, I should take this. Okay, let me take this just a minute. Let me take the same file in Colab and let's see if it is working or not. Something which is okay. So if I restart and run all this, if I restart and run all this, we'll require a file over here that is companies.txt. Let us upload it first. This is your file. Let's take it. Yeah. Let us take this. This will throw error, obviously. This will also throw error. Let's take this now. This one. Here also it is throwing the same error. Okay. Characteristics inside a video body. Okay, let me check this. But what we are doing is, anyway, this is little advanced for you. I understand. Let's continue this with tomorrow's session. But as of now, you just need to have this idea that Beautiful Soup is a library that we use to do the web scraping. I mean, take data from the websites directly. This is first thing. Second thing that we have learned is to connect the SQL data. This is your second uh, thing. And third, I think we have seen is the encoding part. How do we read a tab separated file with encoding this? So we have seen three different scenarios, right? Right? I'll quickly upload this file on your drive so that you can uh, try this out as part of your homework. And now, if you have any questions, you can ask. Otherwise, we'll just stop here for the day. Tomorrow, we'll continue with the same discussion that we are discussing here. Yeah. Anybody have any questions, any doubts, anything, or any suggestion for me if it is not clear or I need to uh, take it in different way? We can discuss. Yes, guys. Do you have any questions?
No, it will.
So anyway, this is something which is little advanced, as I told. You need to try this out, practice this. And we rarely use web scraping. That is also not something which you guys will require mostly, right? The pandas numpy thing is something which you guys will uh, require it frequently. But this is not something that we do and we go with continuously or more frequently. All right, I've shared the file on your drive. Okay, let's stop here for the day then. Thank you, everyone. Happy learning. Tomorrow, we are going to continue with the same discussion of reading data from websites. We'll see how do we get data from APIs, and we'll see how do we read PDF file. We'll cover this thing. Then a very important part, how do we clean a data set? That is also very, very important part. And right after that, we'll see, yeah, this is what we have. Then we'll start with the SQL module, right? So that will be our agenda for tomorrow's session.
So in tomorrow's module itself, we'll be covering class and objects also, Vipul.
Class and objects, yeah. We'll cover that.
Okay.
All right, everyone, then thank you. Happy learning. Bye.
Thank you, Vipul. Bye.